Hey, what's up, guys? So we are going to solve this valid BST problem from interview bit. And say interview bit. All right. So what this problem says? So you will given a pre-order traversal of a binary search tree, and now you have to you have to tell that whether this pre-order traversal of this binary search tree is true or not, is valid or not. Fine. So you may be thinking like, what is the solution? So let me explain you. Fine. So the most optimal, the first solution comes to your mind is, suppose I'm making a tree. Suppose this is my 20, and this is 15, 20, 15, 30, and this will be suppose 10. Then I will take 5, then I will take what else? Okay, suppose 12, now 11. All right, and fine, 25, sorry, 25. All right, fine. Okay, fine. So let me tell you one thing, that the example given in this is wrong. I was quite confused for a long time, see for 22 20 minutes around. So this is actually wrong test case. So what can be the correct test case? All right. So why this is wrong? Because I will explain you why. Suppose this is our the example test case given, and suppose this is our 10. Then this will be then we have 7, right? First is our 7, then we have our 10, then we have again 10. Suppose this is left bias, then I'm making 10, then I got 9. All right, fine, I got 9. Then again I got 5. All right, fine. Then I got 2, then I got 8. So this is impossible, this can't be happen, right? I can't get 2 of 8 after 2. So 8 will be somewhere between here after 9. All right, so 8 will become after 9. So that's why this is invalid, totally invalid test case. And the output here is, you can see, uh, output here is 1. So this is a wrong test case. I guess not I guess this is actually wrong test case. All right, fine. So let me explain you. Suppose this is our BST, right? Binary search tree. Now I will give an example. I'll give a test case. Fine. So what do we had? We have 20 first, right? So I'm writing here in the below 20, then 15, then 10, then 5, then 12, then 11, then 30, then 25. All right, then 25. Fine. So the thing is, you can see this is a valid BST. Now what for this binary search tree, I can have many other type of configurations also. Suppose this is my 20, and this is my 15, and then this is my 12, then 11, then 10, and then 5. So this will also hold true, right? If I write it as where I write, okay, fine, here I will writing 20, 15, 12, 11, 10, 5. So this way is also correct, and if I write this way is also correct, right? So what I'm trying to explain you is that there can be multiple configuration of the same numbers. But so what is the distinguisher point between a valid BST and a non-valid BST? So you will say that, okay sir, what we will do is we will this is our root. Suppose this is our root, and we will check. We know that if there is a greater value in BST in root, which is 30, right, which is 30. So like I will check from 20 to 30. Fine. So if I am getting the first greater value, then I am in the my right subtree. Then after this, if I find any less value which is less than my 20, then we have to return 0, because the BST condition will not hold true. So we just can't simply do that, because we will have left subtree also. Here we can also have that wrong configuration, right? So if suppose that we can't fix the root as just 20, because at every node we are visiting, we have our root is changing, right? So our 20 becomes, then 15 root becomes, then our 5 root becomes, right? So this way our root value is changing. So what would be the optimal way? So so this is the solution. Like what we will do is we will this is our node, and this is our all left subtree, and this is our right subtree, right? So we will store our node value in the root.
आज जोड़ देना था इनको,
अच्छा,
है ना?
ठीक।
ये 5-6 बजे ना,
ठीक है।
अरे अपसेंट हो जा रहा है जोड़ देना।
We'll store our root value, right, in a root. Suppose I'm storing the root value in our root. So if I'm finding any bigger value than root, okay, fine, that means I'm in my right subtree. Now if I find any value which is less than my root value, then we have to return 0, because that will make our condition false of BST, right? So this we have to check for every node value, right? So let's code it. So for that purpose I'm gonna use stack. So fine, I'll code it. So this is my array we are getting. So int length will be array dot size. All right, fine. Now what I will do, I will declare my int and I will put my stack value as stk. So this is my core concept, that what I will do is as I told you, that this will be our node, and in the left subtree, this is our left subtree, suppose, and this is our right subtree. For each node, what we have to do is, if I am getting the first next greater value, then we will enter into our right subtree now. And if I am getting any value which is, suppose here we have 10, and if I am getting any value in this right subtree which is less than equal to 10, suppose we are getting here 5, then this is invalid and we have to return 0 here. And we can get as many max greater node than 10 in this side, but we can't get any single value which is less than 10. All right, fine. So this will be our approach, and the most optimized approach is stack, by using the stack. So let's code our solution. Fine. So I have made int stack stk, and int root equal to, I will consider it int minimum value. Now what I will do is I will put the first element into stack. So stk dot push array of 0. All right, now what I'm doing is while stk dot size greater than 0, right, void stk dot size till our stack is not empty, means and our array of I will what I will do is I will pop out all the element from the stack, stk dot top. Fine. So what I will do is I will my first I will save the root value as stk dot top. Now I will pop out from my stack, so stk dot pop. All right, fine. Now after doing this, what I will do, I will push whatever element, the present element, into my stack. So push array of I. All right. So the first thing I have to do inside this while loop, so this is our condition, right? So I have to run my for loop from int I equal to 1 to I less than length, then I plus plus. Now the first thing I have to check is whether this our root value is less than, or array of I is less than our root value or equal to. Suppose we have our left biased tree. So if the root value is same, then if any value is same, then we will put in the left part of our BST, right? Then we will simply return 0 from here if this condition happens. So as I told you, what this tells is, if we are getting any value which is, suppose this is our 10, and if we are getting any value, any single value which is less than equal to 10 in this right side, then we will return 0 here from here, right? Fine. Now and if all this condition satisfied, if we reach the end of our array, then we will return 1 from here. Fine. So I think this solution seems correct. Let's test it. Correct answer. Fine. Let's submit it. All right. So I got 75 points, and because I wasted a lot of 30 minutes around thinking about the solution, like what could be the possible solution, then I finally come across this solution. Well, I have seen some YouTube tutorial, and I'm explaining those tutorial, because they didn't explain it clearly, like what is the root cause, how we will solve. They just put the solution, and this is my first explanation. And tell me if this helped, or what I can improve. I know I'm a beginner, and this tutorial might not be very good or good even. This is, I know this is worse, but yeah, let me know what you feel. Fine. Thank you so much.